Okay, welcome. Thanks for joining me. My first brown bag at Open People. The brown bag is title promises, I'm not monads. All right, so basically for the past year, less than a year, I've kind of been on and off like studying functional programming. Mainly because like there's been like a trend emerging. JavaScript has been said that JavaScript is a functional language because functions are first-class citizens in JavaScript. And another thing that's floating around is promises of monads, or monadic. So I spent a fair amount of time trying to understand this, and one of the things I want to start off with is try to explain monads from my point of view, and hopefully in a way that I hope is understandable to everybody. First of all, how many people here have used C#, and more specifically in C#, generics in C#, or heard of it? So, majority. In Java, there's something similar. Basically, you have like a list of something. That's basically what I'm talking about. So generally, when you define the list type, you don't say this is a list of ints or this is a list of strings, because then you have to create one list type for every type of thing that you're doing. So there's a feature in the language that you develop for which lets you say this is a list of any type, and let it be defined when you construct it. That's quite important for this. So here's a list of example types that exist in some functional languages, which are basically monads. And so I'm going to go through these and just sort of describe what they are from like an English perspective. So list of T basically represents 0 or more values of type T. A maybe of T represents 1 or no values of type T. An either of A or T represents a value of either type A or a value of type T. A future of T represents an executable with a return value of type T. A state of A and T is an executable that takes an initial value of A and then returns a value of type T and a new value of type A that would represent the changes that in that initial value that you provide, which is your state. That one's a little bit harder to kind of describe in terms of monad, but you can kind of, in the same way that you inherit a type and create a new type, logger is basically a type on top of state, which basically it defines A as like exception, for example, or string. So you don't have to worry about that. So a logger of type T is a monad that basically value type T with a list of, say, strings. Okay, cool. So yeah, a logger of type T basically allows you to it allows you to run a bunch of execution, but at the same time keep a track of logs, like errors that have been happening along the way, or things that you want to, not necessarily errors, right? Logging. So that's why that's state. Either is usually used for exception handling, because either is a little different. Either, whenever you get an error, it will hold no values of type T and then sort of stop execution. So I'm gonna move on from there.
Okay, yeah. But really quick, the logger of T. So what does the T do for the type of logger? So do I get like, what does that type help for logging?
Yeah, I realized that with that particular type, it's hard for me to explain. So
okay, we can wait for your logger of type 2 from back.
Sure. Yeah. Okay. So basically, monads tend to represent an inner type. They can represent 0 or more values of that type. A monad is basically a type that adheres to a pattern. For example, an application context in .NET is a singleton. In the same way, a list is a monad. So something being a monad doesn't necessarily define what it is or what it does. Something being a monad is an abstract idea. It's almost like saying these things are living organisms. You know, a lot of them speak, a lot of them walk, a lot of them breathe. But what does it actually mean? What does it actually mean for something to be a living organism? That's how abstract monads are in something as well. So I like to call types monadic, just because it helps, like, it takes away from this idea that monads are a thing. They're not. It's just an idea. And yet the purpose is defined by their types. And some more notes here, which I'm just going to skip past, to be honest.
Apparently, there's also a piece of
It's true. We can smell it here too. Okay, so what makes up, what things do you have to do with a type for it to be monadic, for it to be a monad? It basically has to have two functions. One of them I'm calling from. In other languages, they also have the name unit, of, pure, or return, and possibly others. Basically, the point is that whatever the method name you choose, it should be the same across all the different types that are monadic. And the other one is called flat map, which again has aliases like bind, fmap, then, or in Haskell it has like a weird symbol that represents that function. So in order to satisfy these functions, the type needs to be generic in some way, right? So the from method, it should take, in JavaScript, you could consider resolve to be like this from method. So it takes a value and it gives you an instance of that type that represents the value that you just gave.
It's not the promise that resolve? Or
Yeah, okay. One thing I'm trying not to say right now is that monads holds the value, because like there's all these, like you read this online a lot, and it's not technically true, and people just say, hey, it's not technically true, I'll just say this for now. No, it represents the value. Flat map is basically a function that kind of merges two of the same type together. So we'll go into details a little bit there and give some examples.
Can you clarify the difference between represent and
Yeah. Well, like if a type contains a value, that means that it has the value, it's already evaluated, and it's sort of like internal state, right? But when it represents it, you know, I'm being more generic in the way that I'm describing. I'm saying like it could hold the value itself, or it could hold a function that will eventually give you the value. It could, and generally like it represents it, because it's like it can represent 0 of them, it can represent 1 of them, 2 of them, 3 of them. So like that's why I'm trying to use that. So it's a little bit more generic, so it does kind of encapsulate having the value as well. It is a container. Yeah. Okay, so one of the things about the from method is it should be pure. So when you do like promise dot resolve, or you do array of number, for example, it shouldn't like add any special state to this type or do anything like that could compromise the ability to like change your type together. And I think this again will be more apparent soon. All right, so for something to be a monad, it needs to follow a set of rules. These are like mathematical rules that kind of, if you don't adhere to them, you're just not following like, it's not a monad, it doesn't really follow the pattern. So it's not enough for the type definitions for you to say this thing is a monad, you have to also adhere to these laws. So basically, if I say like promise resolve 1, and then I say then, and then I give it a function that sort of says take this value 1 and multiply by 2, then what you should get back is a promise of 2, right? And that's the exact same thing as if I just called the function with the value 1. If I multiply by 2, I get a promise of 2. So that's like one, that's called left identity, that's one of the laws. In actual fact, I've got an example here of using an array. So if I have an array of one value, which has 10, and then I flat map it, give it the function positive and negative, which basically give me an array of 10 and minus 10. It should be the exact same as if I just gave the value 10 to the function positive and negative. Right identity is basically this is trying to enforce the same thing, but from the reverse side. If I have a monad, which already represents a value, and then I give it the from method, it should pretty much return a new monad that is identical to the last. Like, apart from the fact, like in languages which have like references, it might have a different reference, it might be stored in a different part of memory. Other than that, they should be pretty much identical. So if I have like an array of 4 values, 1, 2, 3, 4, and then I flat map it, and I give it the function, you know, the unit function, the from function, which in array space is just an array with 1 value in it, I should get back the exact same array, 1, 2, 3, 4, and they should be pretty much identical. Then the last law is associativity. And basically this is kind of enforcing that the order in which you call your flat maps, like, it shouldn't affect the outcome of composition. These rules are actually important just so that, like, later on when you're building your types, like, you can trust that, you know, you can start building on it. Because if you know that these laws are true, then you don't have to worry about like edge cases and stuff like that. This is what these laws are there for. And I want to go into a demo where I'm going to show a quick monad, but it's going to have a problem in it, and I'm going to try to explain that. Escape. Okay. How do you? Okay, I need to zoom in this one. And close this.
Is the problem going to be there on purpose?
Yes.
Oh, okay.
Yeah. Can you guys see this? Or yeah? Yeah. Cool. So I've got here a JavaScript class. I call it historical. It has a constructor which takes a value and then some sort of history value, which is going to be.
It's me, Ricardo. We're recording this, by the way.
Yeah.
Twice now. 3 times you're out of here.
In this class, I have 2 functions: of, which is basically our from method. So like it's a historical of the value, and record. Why did I create record? Oh, I just created an alias. That was what that was. Because in my example, when I'm writing the code, I felt like having an alias of that function made it rego. So yeah, and you got the flat map function, and the flat map function is usually where the most of the logic goes, like how you compose your monads.
So this is the one that.
This isn't a monad, but this is something that attempts to be a monad.
Okay. Okay, cool.
Yes, bad monad.
It's
Oh, right, yeah, okay. Okay, cool, I got it.
And so what I've got here is I create a historical of 30. So I called it record. So basically you've got this type and you say, hey, record the value 30. And then the next thing it does is it goes, oh, now record the number 20. And then finally record the number plus 40. So in total you should get a record saying 30, 20, and then 20 plus 40, 60. That should be that should be the internal state that it's recording. So that's what this type kind of does. And then in the second example here, I am doing pretty much the same thing, but I'm doing it slightly differently. So I'm saying, hey, record the value 20, then record the value 20 plus 40, which is 60. And then I'm saying, oh, by the way, prepend to that record the value 30, because I'm basically saying, like, the total chain is actually historical. It's the same chain. Like, it records 30, then it records 20, then it records number plus 40. But I've just like rewritten it so that in terms of time, it's the opposite. It's different. So these two, according to the laws, should yield the same output. And if I run that now, you'll see that they both like contain this, like they still represent the same end result value. But the history, the internal history that they're holding, the first one holds 30, then 20, then 60, but the second one holds 20, then 60, then 30. So that's the problem. And the reason why it's doing that is I made a bad assumption in here. So I've done this on purpose, but whenever I get a function passed in saying, okay, this monad has this function needs to execute based on the value that you have now, and it needs to run it in the correct order. I return a new type of a new value of my type, which basically represents the next value that the function would produce, as well as any sort of internal state that I want to hold. And in here, I made the assumption that the largest history from either like both these types have an internal state, which is I'm saying that the one that has the largest history should go first, and the one that has the smallest history goes next. And so, in the second example, what I'd done was I'd already built up a state of 2 records, and then I sort of said prepend the other ones, and it put it at the end into the smaller record. So if I were to delete, like to fix this, if I was to like just delete this and go, hey, I just want to take the history from the first monad by myself and append the history from the monad returned by the function, everything would be running fine, and this would actually be a monad. So that's kind of explaining the laws a little bit better, but from like a more developed point of view.
So which law did this break?
This broke just the associativity law. Yeah, cool. Okay, so now I'm going to go through those types that I was talking about, some of them. And it's going to start with the list monad. So basically what I'm trying to do here is prime your brains a little bit to think a little bit more. Like when you think of a list, you're thinking of this array of values. You think it has these values. You think that you know, I can get its length and all this sort of stuff. So the monadic part of it is just a subset of what that type does. And I want to try to just focus us onto that. So when you're looking at it from like a monadic point of view, a list represents non-determinism. And what that means is basically like when you do an operation, you don't know like how many values you're going to get back from it. You don't know like which one of these values are like they're all pretty much equally valid answers. An example of this is if I were to ask the question, hey, what position is a knight after one move from the position d4, then the answer is actually non-deterministic. There's actually 8 different answers you can get. It could be b5, it could be c6, it could be e6, and I'm not going to keep reading the board. However, at the same time, you know, if the knight was at like h1, then you've only got two values. So basically, like this function is non-deterministic. And then this sort of tree thing on the right here, it kind of represents like, you know, once you've done that, you might want to say, hey, what about after 2 moves? Well, then you give it to the same function again, right? But now you've got a list of values, and you can do it for each one of those values. And this is what this monad pattern allows you to do. It allows you to kind of not worry about oh, now I have 3, so I have to call it 3 times. Like it just goes, no, just ask this question, and then ask this question again, and then ask this question again, and then what you should get back is a list of all the answers of the final question, which was like, where would the knight be after 5 moves on the chessboard, starting from this position? Like, where could it be? And there's like a bunch of answers. And interestingly, if at any point you end up with no values, you can't, it stays 0. Yeah, it just doesn't really move on from there. And I'm going to show an example of the list monad in action, so that we get something tangible to look at as well.
But to me, it seems that the problem itself is not deterministic, not the type you use to represent it. Because I can find another situation where our list is completely deterministic. I can think of a problem, and the answers are 1, 5, 7, 8, 12.
Yeah.
And I'm using the list, and I'm giving you a deterministic
Yeah.
set of values.
Well, I mean, like in terms of the monad basically is there. Like you would use this like monadic syntax. You would use it as a monad if you're dealing with something that's non-deterministic. And being able to think of it as a non-deterministic type allows you to kind of think about how you're going to chain your functions. I'm going to give a slight. Well, hopefully. I mean, we can talk about it a little bit more detail. Maybe this is something that.
Like I can use a list to model Fibonacci's.
Yeah.
It's that it's not non-deterministic. If you start by 1, you expect what is.
Yes, but if I
That's why I don't get the matching of the type with the problem. The problem is not deterministic all the time, seems to me. Or
no,
maybe if I have
the
a
type will hold an indeterministic number of values, right? So you can give it to that function, you can give it to another function, you know, like there's like an infinite number of functions or questions you can ask, but the type itself is the thing that holds all, like represents all of those values. And I mean, like from that point of view, without thinking about the actual problem that you're trying to deal with, just from the type's point of view, it's modeling non-determinism, because it can be. You know, it can be returned from a function that just said, hey, give me 1 to 10. That's not deterministic, I guess. But then from there you go, right, now give me the square roots of them, now give me the, right, and so on. Like, and at the end of it, what you've got is a list of values. But, and actually another thing you can represent sometimes is an infinite list, for example, in some languages.
And from the topic, what is it about monads that make it non-deterministic? If you can come up with types that. What's that?
Well, okay, let me show like why it's useful from like a code perspective. So here I've just sort of added a flat map function to my array type in JavaScript. Just for the sake of allowing me to give you this demo. I have 3 functions. By the way, these aren't real functions. They don't really do what they say they do. I've got solve x, which is basically the idea of if I had a quadratic equation, so ax squared plus bx plus c, and that constant in each case was 1 value, and that value, I'm taking the value x here. Like, what is the, I should rename this from x to like a something k, right? But sorry, that's not that. But you know that you get 2 values from that quadratic equation. So that's what this does. Is like based on this constant k, what are the 2 values of x that you can get? The root function basically gives you the square root of a value, which is usually the negative and the positive of a number. And primes, this is kind of a function that would give you all the primes of a number, given a number. In this case, this is going to just do a random set of 5 numbers. And generally, if you wanted to like compose those functions, like want to do one, then do the other, then do the other, and like get a list of answers, this is kind of code you'd end up with. Like you have a for loop. So I start off with a list of 3 values: 20,000, 21,000, 30,000. And then I kind of go through each of the volume values, and for each of them, I solve the quadratic equation. Then, for each of those values, I then loop through those, and I solve the root. I ask for the root of that. And then for all of those values, I loop through it, and I get primed. And then finally, I get a big array of all the values. That was the answer of this whole equation. When you have a method like this, flat map, which an array would like in some languages, the array implements this. You just have to say this: here's a list of values. Now I want you to find the quadratic equations, and then from those values, I want you to get the roots, and then from those values, I want you to get the primes. This is why it's useful. It's like it reduces all of this noise. And I think that's what I want to focus on. I don't really want to talk too much of the mathematical stuff, because it's really hard. It's hard to explain. It's hard to describe. It's just. But I think this is where you kind of go, aha, it makes sense of it. And internally, this is the implementation of it. I just I take my function, I loop through, and then I run the function for each one of those values, and I create a new array and I return it. So this is encapsulating all of that nesting. And this is actually a common theme in most monads as well. It basically encapsulates some sort of nesting. So in promises, for example, it was encapsulating the callback hell, right? Let's go back to the. Okay, so the next type I want to talk about is the maybe type, which is all right, so let's say we're searching for some value in a data structure, and we can find many dead ends along the way, because a property that you're reading into might be null. You can end up writing quite a bit of defensive coding. It's okay, so first of all, check if this value is null. If it's not, okay, now check this value, and then one of those values would be a reference to something else, but that could also be null, and then so it's not necessarily just always reading a property along one line. It could be okay, based on this value, is it true? Okay, then read this property, otherwise read this property. So the traversing of a data structure can be quite complex. But one thing that's quite common is if this thing is null, stop execution. I'm not going to find this value anymore. So without having to write all of that noisy code, the maybe type kind of encapsulates that part of it for you. And so you can kind of say, hey, this is an example of pseudocode that I've written, which is I have a string called hello Michael, or it could be an input, right? And so I start off by saying maybe from, so I create my maybe type, and that represents the value hello Michael. And then I say, okay, remove the value hello or return nothing. So if there wasn't a hello in there, at that point it would stop. But in this case, it returns a just Michael, which is a maybe type which represents the value of Michael. And then finally get the 10th character. And at this point, there is no 10th character, so it returns nothing. But if there was a 10th character, it would continue. And then the final thing that it might have done is uppercase. So in this case, I'm showing something which is a bit interesting. You've seen in arrays and that stuff, you have the map function. The map function is actually just a combination of the from method and the flat map method. Or at least it can be represented that way. So the uppercase function would be a function that takes a string and then returns the same string but uppercase. So it doesn't know or do anything to do with monads, right? So in order for us to put it into this chain, we need to kind of do, okay, flat map, this value, give it to the uppercase function, that gives me back a string. Now I need to lift it into my maybe monad and then give that to that flat map function so it can continue the chain of execution. And then finally, when you get back, well, I mean, so that line would never really return nothing. It's not going to happen. But by having it in the chain, you know that when you, if at any point in this chain you get nothing, it's not going to continue execution. It stops serving, and that's what this type kind of represents. And then when you finish doing your chain of execution, at that point you take your type and you go, right, now you start using all the properties that are non-monadic, things that like has nothing to do with the monads at all. It's just about the maybe type. So does it have a value? Yes, in logged success, and here's the value. And otherwise, log, oops, there was something went wrong. So that's how you might use a maybe type. And so you can see like there's a separation of like the type itself and this small composition ability that it has. Now I want to talk about procedure notation, which is basically like in JavaScript we have the async await for promises. In C# we have that for tasks, but in languages like Haskell, you have this for pretty much all monads. They basically have what's called a do notation. And you start off with one monad, so it might be the monad, the main monad, an IO monad, whatever. And you can use a syntax that kind of looks like this, that allows you to have code that's more understandable for like us type of developers who of course used to writing this in this type of way instead of like then, which is a little more declarative in my opinion. And then it returns a value of that same monad that you started off with. What's interesting about this is it actually allows you to keep variables in scope without needing to nest the chains. So like in promises, I'm sure you noticed like when you get a value from one of your promises and then you want to like do something else, and then you want to get the value from both of those actions and use them in the final thing. You kind of need to do promise.then, get your value, and then kind of do this thing, and then internally do another then, like nest your thens in order to get access to the value from the previous then. Like you don't need to do that anymore because basically all the variables stay in scope now with this syntax, which is quite interesting. It's just a nice feature of it.
Or promise that all.
Promise that all, just do. Yeah, that's also just okay, but yeah, so in general, like, the common themes of monad is to remove the craft from your code, so that you can write something like this. So if this this is just procedural looking code now, but in here there's all that null checking is actually going on. This is the exact same code that we were looking at before. But you can see that there's not like if this is equal to null, blah, blah, blah in there. It just comes out with a maybe at the end. So here, this is the either type, which I've called it either A for the sake of this monad, because monads can only really represent one value type, right? It's always the last thing. So if you have a generic type which has like T1 and T2, it always represents T2. That's the only thing you can work with. This is quite limited in that way. And the either type, most people use it to model errors. So they take the A and they say that's exception, that's the type exception, and then the right value, which is the value that we're composing with. We're going through the chain this value. So this has two constructors, this type. Usually it has two static methods, right and left. The right function is basically your from function as well. It's just an alias. And basically, when you create it, this is an interesting one. When you create it, I mean, maybe not in JavaScript, but at least in a strongly typed language, you have to specify what A was going to be, as well as what B is going to be when you create an instance of it. And when we create left, we still have to specify what B would have been if there was value, but also here's the error for the left value. And what this type represents is I'm going to store either one of a value of type error or a value of type whatever type that specifies string. Yeah. So here's like an example of usage. I have a divide function. I might have to zoom in a little bit on this. So I have a divide function. And this divide function, instead of like letting itself crash, it kind of does some checking and then finally returns value. So first of all, it just like checks whether y is 0, because you know that will give you a divide by 0 error. So if that's the case, it just returns an either of right, which is like an error. And it gives you, in this case, in this code case, the error type is true, no exception. Yeah. And I'll just give it the error, cannot divide the value by 0. Then the next thing I check is, hey, is it, does it divide like equally? Like, will it give you some sort of remainder? Because if it does, this thing returns an integer. That would also be an error. So I check that, and I give you that error back as well. And then finally, once I've checked that, I then go, okay, here's the value. The value is x divided by y. So this is my safe divide function. And the way you use it is similar to the maybe type, in that you would do your composition, you divide, you maybe compose other functions that also return eithers and so on, and you get back this value. And then finally, at the end, you kind of go, okay, well, is it successful? And you know, the function for this is called isLeft, because the type itself isn't actually an error checking type. It's actually an item. But a lot of people use it for error checking. So this is why the syntax is a little bit off-putting. And I don't recommend using it, to be honest, for that type of trick. I would have better function names. But anyway, so yeah, it's isLeft, which basically means was it successful? And if it is, then do something with that value. Otherwise, you know, get the value from the sorry, left is an error. Left is an error, right is a success. So again, if it's left, then you've got some problem. Do something, handle it in some way. Otherwise, if it's right, you've got your value, do something with it. And then once you've got your value, maybe you want to send it to you might want to continue composing with other types of monads. The final, I think that's the final one I want to talk about. Yeah, the final one I want to talk about is future monad. And this one's interesting because in this type, you really don't hold the value. Like, you're not really evaluating these functions as you chain. And by the way, these are not promises. Promises are similar, but they're eager, which is probably going to have a completely different internal mechanism.
So can I ask?
Yeah.
Should I wait till you're done? Okay, just asking about what you were just saying. So like, when you're talking about laziness, are you saying that the actual evaluation of the value inside of the type does not actually get evaluated, if you will, until the end of the chain?
That's correct.
Whereas it promises it's for boxing and unboxing.
Well, so with promises, internally they just the implementation internally just like wires off the execution as quickly as possible. It queues that stuff to happen and it adds it onto the event. JavaScript event loop. Yeah.
Yeah, full of JavaScript.
Anyway, one thing I want to introduce is a thing called a thunk. So a thunk is, when I say the word thunk, all I mean is a function that takes no parameters and returns value. And here's the simplest one. It's a function that returns the word square. It's a thunk. Takes no parameters and returns value. Here's a slightly more complex one. And this in here, I'm taking advantage of scoping in JavaScript to basically give myself a parameter but return a thunk. So I return here a func, which is a function which takes no parameters and returns a value. But what it does internally is based on that final file name parameter that I passed in when I created thunk in the first place. This is a pseudocode of like something that could be in like promise.read file or something like that. And inside, because it's like language code, it tends to have, it might have some like operating system type level code in there. So in here, I basically get myself a handle for reading a file. I tell it what file to read. And then try to get the data from that handle. And at that point, I tell the operating system, hey, wait for this as well. So that what's going to happen now is that the operating system is going to manage it. It's going to go, okay, well, I'm going to stop execution. I'm going to pause it. I'm going to take it away, and I'm going to make sure that that thread is open to anyone else who wants to carry on using it. And then when that hard drive is ready to give me the value, then the operating system is going to spin back up and go, okay, carry on now, here's the value. This is like not something that we would write ourselves. This is something that would be internal to the library, to the language. And then return the context. So this is a thumb that is kind of asynchronous. And yeah, just move on. Okay, so at the top, we have an example of composition of a feature. So I say feature from the string readme.txt. I want you to read the file, so feature.read file. And then finally, I want you to get me the first 20 characters from that, from the file. And the bit underneath is, I want to try to build up this mental model of what's going on inside of the feature type. What state is it holding inside? And basically, it's something like this. Let's go through this like step by step. So I go future.from readme. Internally, what I create is a dump that just returns the string readme.txt. So if I was from now on, if I was to say, hey, remember that feature, like execute it, what am I going to get back? Readme.txt. Next thing I do is I call, I'd say, okay, the next thing you need to do is call read file. Now, instead of taking that value and then executing it and giving it to the read file function, what it does is it creates a new dunk, it wraps the old dunk, and it kind of says, hey, the new dunk is going to get the value from the old dunk and store it in this variable, and then it's going to pass it to the read file function, and then it's going to return that value. So it's done it without executing anything. It's just, composing the functions. And then finally, when you do the get first 20 characters, it does exactly the same thing. It wraps the other dunk internally inside another anonymous function, which basically, and then waits. It says when I get that value, I want to give it this get first 20 characters function. That's going to give me the value, and it wraps it all inside a function, so nothing's executed until you actually call that function.
So is it fair to say that the purpose of thunks are to enable this like lazy instantiation? So
the purpose of futures is to do this. Thunks themselves is just a word that mathematicians, whatever the type chose for these types of functions.
Right, but I'm saying we're using thunks here to basically return a function that takes no parameters, right? So that the function itself can then be executed.
Correct, without having any sort of value provided to it. And you just, so yeah, like all the information that's ever needed for the execution is already inside this thunk.
So instead of actually returning a value,
we're returning
maybe a value is not the word, but
yeah.
you know what I mean.
Well, you're returning a function, which is a value in functional languages.
Yeah.
But yeah. So to summarize, monads simply require the presence of two functions, which is your from function and your
Flat map.
I was like line
Apply.
Monads must generalize over one value type, or it should at least make sense to generalize over the last value type. That's the caveat, which we've seen with either and what we've seen with state. Well, I didn't really talk about state, but it's fine. Monads should follow a set of laws that basically, if they follow those laws, then it allows you to compose your monads and write code like we've seen without worrying about, oh, did I do it in the right order? What's going to happen in this edge case or that edge case? It's a little bit like aspect-oriented programming in C#. Any of you ever worked with that a little bit? In that it allows you to write your functions, and all the stuff that happens like before or after it is encapsulated, and it kind of, it's like error handling, traps it, is encapsulated and all that sort of stuff. It's quite nice. It can be thought of as a little bit like aspect-oriented programming. There is a difference. A monad can represent 0 values, and at that point, if they do represent 0 values, they start composing, and that's by design. That just happens to be like any monad, any monadic type. Some types don't allow representing 0 values, and that's just the nature of that type. But in general, they can 0 to n number of values. Types are free to expose whatever internal state that makes sense. So as we've seen, like the either monad exposes, do I have an internal value? Is it left value? Is it the left type or is it the right type? And then it gives you the value if you ask for it. Like it just exposes it, and that's fine. Like the monad doesn't restrict the type from doing anything. But monads basically remove craft. You know, they let you like remove all of that nesting and stuff like that. But also having the types follow a pattern, having them, follow the pattern, having the method names the same, it allows us to, build functions over it. Lets us abstract, build help functions and help tools around these types. And I think that's where most of like the craze, the trend, like all these people going, oh, this monad, I need to know what this is because of this. Like a lot of people are like boasting about how nice it is to get all these useful convenience functions and stuff. And they're like, the only reason is because they're monads. I think that's about it. I've created a monad of mine, and it basically took code that looks a bit like this to code that basically went, that's all. Because I removed all the product. And I've got a link to my GitHub so you can have a look at it, and then later on we can talk about it. I don't think I'm going to go into detail for a long time. Let's start with that. I've done that. Yeah. Promises are not monads, but why? So at this point, does anyone want to give any any ideas of why promises are not monads? Yes.
Kind of like potentially what I was alluding to earlier, maybe the eager instantiation of the functions on the chain.
Yeah. Any other like? There's a few I can think of like off the top of my head based on what we were talking about. True. It was one of those. No. I think that there is a little bit more to monads than just that. I think that when you're learning about monads, this is what I just talked about, is what you learn. Because I since have been reading a bit more into it, I'm pretty sure. Like, Rob sent me a tweet from, was it Uncle Bob? Did it start with Uncle Bob?
Or I started with Uncle Bob.
Yeah.
And I read it and it didn't make any sense, so I go, can you explain this to me? And then he said he read it on WhatsApp message. I go, I'm not reading that. I'm supposed to tweet
in there, like, he asked basically, is it, do people who understand monads believe that languages that are eager don't actually implement monads, because that would explain it. And that people like trying to explain it. I think that might be the case, but I haven't. Maybe like when you read further into it and you get like even better, deeper understanding of monads, like you'll get an understanding of why it being eager makes it not monad. But that's only one. That's one of the potential reasons why. Like another thing could be, for example, okay, well, your then function, it's not actually associative. Like, in order for it to be associative, it needs to only be able to take in a function that returns another promise. But our then function takes a function that returns a value and then continues chaining. Well, at that point, you've actually broken that law. For convenience for developers, sure, but you've still broken it, and therefore you can't, like, when you want to abstract over it and build other functions over it, you don't have the safety of knowing that this is how it is. And so it therefore doesn't follow the pattern, as an example. But actually, the main reason why I say promises are not monads is basically this thing. So I found like a RFC, request comments, when someone was saying, hey, can we do this thing to make the promises more monadic? Like, can we do this thing so that the then only takes in a function that returns a promise, not like value? Or can we do this? Can we do that? And there were like reasons why they didn't want to do it. They didn't want to change the spec. One of them is to keep interoperability, to like keeping it to a minimum is quite important, and it's important to the success of promises. So promises were first being introduced by libraries before the developers made it into a core part of JavaScript. And because of that, they want to make sure that they can identify other people's promises and then keep them going. And so in order to enable that, they've said, hey, if there's a then function, like then it's a promise, and here are some traits of it, and they're not the exact same as the laws of the monads, but it's perfect for the JavaScript ecosystem. There's a lot of people are saying in the same thread there was a quote. These are quotes, by the way, except for web keeping. No need to redefine promises, which are tailored to ease the pain of asynchronous coding with imperative stuff. Promises were designed to ease the pain of asynchronous coding with an imperative style. That's it. Like it wasn't there to be functional, it wasn't there to be monads. And finally, from a blog post, promises were invented, not discovered. So one thing about monads is they were born of mathematical proofs and ideas. And if you want to call something monads, you need to build it with that in mind. You have to build it to follow those laws. And if you haven't, that's why I say it's not about that. And I don't think it ever will be, not for a long time, because clearly the developers don't see that. It's a theoretical concept. Like, why is that useful? No, this is a language, but it doesn't really work. Let's not try to make it into something it's not. And that's basically it. That is why.
Would that be the only benefit of making these monadic is keeping them pure? There's not really any.
Yeah, I mean, keeping them pure. I mean, so in functional languages, where they have built them to be monadic from the ground up, right? Where they don't have to deal with people who have already hacked their way around the ecosystem because they weren't there like that. That's actually a little bit more useful because you get much more convenience functions, and you get you get more support from the language and the interpreters and the compilers. But in the case of JavaScript, I don't think it's as valuable. Also, in the case of a non-type language, I feel like it's actually very difficult to get a lot of the benefits. So in a language like Haskell, a lot of the lazy evaluation, the ability to create infinite value arrays, and then sort of take 5 of them at the end once you've done a bunch of calculations. All of that can be optimized by the compiler. And also, when you do things that are this abstract, you tend to write code that's a little bit harder to maintain yourself, and you need a compiler that's type checking for you to make sure that you're kind of not breaking anything as you're going along. Like, I tried to make a React application, and I might talk about that later, sometime in the future. I haven't finished it, but one thing I found was I was, trying to chain all these different things using these futures. I used the was it Fantasyland? Yeah, future thing. I tried to chain it all, and one of the things I kept coming across was I kept returning, taking functions that weren't returning other futures. They were just returning values, and I was accidentally composing them, and then that was breaking things. And there's no compiler there to stop you from doing that. And I think that's quite important. So yeah, I think they're less useful as well in non-type languages, although they're hard. But yeah, and so okay, there's this here, github.com/monads is a link to my repo. In there is the example of where I said I made a monad of my own. That code is there and it runs. You do have to use the npm command because it uses a harmony flag to enable some advanced features in JavaScript in order for it to work properly. And also the examples that we showed, about bad monad, the list, the composition, all of that code examples there as well. And a README, which basically goes through all of this. There's actually, this was based off that README, is in there as well. Right, so this is my own custom monad. Okay, so let me go through it really quickly. my previous company, I had an application that all it did was it took data from a Mongo store and it synced it to a session. It synced it to a losing index, which was controlled by Solar, which is a technology similar to Elasticsearch. Now, what it needed to do, it needed to do this without consuming too much memory, because there's a lot of data that it needed to sync. It needed to keep track of, what was the last time that I indexed, and then also it needed to do error handling. It needed to make sure that, if there's any errors, I need to stop. I need to tell, I need to log somewhere that, I stopped here. Because if you manage to successfully do half the process and then somehow crash, like, you don't want to start again from scratch. You don't want to start from the beginning. There's a lot of data here. There need to be a bit of optimization. So what this thing did was it did the syncing, but at the same time, it sort of kept track of things like how long has it been running, how many products have been updated successfully, like definitely. What was the date of the last updated product that I synced across? What did the job itself complete, and were there any errors? Okay, and this thing which it returns this thing called status. Now, if you think about this function, it's called sync data to Solar. If it's just a function that returns, it should return nothing. It does the thing, it's an action. But in this case, it returns a result which tells you that the state will happen. What I've done here is I've now just taken just a bit where I go, hey, make this query, send it to Mongo, start a timer, start reading from the database, and as you read from the database, start sending data to Solar, and then each time just keep going through until the cursor runs out, and when you finish, stop the timer, and then just exit from the function. But what it returns is, in JavaScript, you might consider this like an undefined. The value that it returns is undefined or null or nothing. But because it's in this sort of async function, it's going to actually return a promise or a monad. This is actually a generic function, so this is actually going to return a monad. And that monad is basically, the internal state of that monad is all that stuff that I was trying to keep track of, the count, the timer, and so on. And I'm just basically, yeah, I mean, it's a bit hard to kind of go through all of it and describe it, but if you have a look through GitHub, if you have any questions or you're inclined to want to.
So going back to what monad is, how does this satisfy social rules?
Well, when you go to the implementations internally, have a look at it. Like, have a look at all the things that you do in the function. Like, if you were to change the order of which I call these functions, like, would something weird happen? Would something unexpected happen? If that's the case, then it's a bad one. It's not a bad. But I actually, you'll see actually my background function is quite big because there's quite a lot of complexity in this particular model. But it does maintain a sensitivity.
Sorry, is that on the previous script?
So this, what you're saying, is using the do notation, or like it's using generators in JavaScript to kind of allow me to, instead of writing .then, just write it as procedure. So you're not really seeing that function because that's elsewhere. But wherever you're doing yield, that's basically what you're doing flat out. Are there any other questions?
I have a comment.
Yeah.
That's a bit anomalous. This reads very succinct. At the same time, I'm wondering what is the price of having such code if you're in a team? Like, you have to explain monads to everyone because it's good to have code which is a bit longer, but it reads like a bit more English. Whereas this reads like, I know monads and you don't. Which you know what I'm trying to say.
Yeah, sure. You're on the scope, and I haven't thought about that. I don't have a good enough answer for you.
No, but it's not. No, I don't want an answer from. I'm just, it's
absolutely.
It doesn't read like monad. It just reads like
Well, what I mean is the other one. You have to get into the monad code in order to figure out. Like,
Yeah,
I mean, that's not the FU. That's the FU.
No, that's, I'll show you the
So you understand what I'm saying.
So like to make this, like I had to. This is it. So the construct is already quite big. You can see the flat map is basically that big. It's quite a big flat map to encapsulate all that. Generally, when functional developers are building monads, they're building things that are still quite generic. They tend to do one thing well. So their flat maps are generally not that complex, and they're easy to explain and easy to reuse. In this case, I created one to remove the cross, but it's for a specific use case.
One really last, really quick, stupid question. So when you write a monad, you can, in the languages such as Haskell and all the other ones, right? When I'm trying to write my own monad, like, is there inbuilt mechanisms within those languages to ensure that that thing itself is a monad and follows those laws, all those associativities?
The laws, no, but the type checking is there in Haskell.
Okay, I was just wondering.
But then, you think of a lot more. Yes.
No, I was just gonna say, I have like a small comment. I don't know, like, who the audience of, if we were like envisioning for the audience of this talk. There was like a period where I myself was also like super interested in monads as well. And one of the things that really helped me, like, to be honest, I think most people don't, myself included, don't like truly understand monads. One of the things that like helped me along this journey towards kind of understanding monads was like starting off with functors, which I think are just a like stripped down version of a monad. Maybe like if the audience for this talk is intended to be people who have very little understanding of monads, maybe to like start with functors.
I think, well, like from my point of view, like when I started learning about functors and stuff, I saw how it built up to monads, but I saw how it built up to monads in a very like in a very functional, developed kind of way. And I felt like talking about that kind of, he's talking about theory and it comes away from like the real, like I don't think it's useful to talk about monads from like, well, for us, from like a theoretical point of view. It's more useful to think about why are they useful, why do they exist, like why should I use them? Why should, and this, like, hopefully from this you've seen like how it kind of removes a lot of crap from your code in general. And you can see like that's my takeaway from it. It's like that's why it's useful. And I'm going through this thing of going through functions first, like it teaches you like the mathematics and like the how it got derived, but it doesn't necessarily tell you why it's useful. Cool. Thank you very much.